Hello, today we're going to learn how to do logistic regression on R. So first thing that we'll probably need to do is read in a sample file here. So I'm going to get this file from dmanalytics.com and the data file is from Retail Relay, okay? And assuming that you probably have downloaded this and read this into R, so this is how the data is going to look like. So it has our dependent variable meaning retained, meaning that whether the customer has been retained or not. And there are several different type of independent variables that we're going to use. But for this example, we're going to use two different types of independent variables. The first one would be average order, meaning that the average order amount in dollars that the customer has placed. Okay, and the second one would be doorstep, meaning that whether the customer has used doorstep delivery service or not for their orders. Okay, so assuming that you probably have your Excel library and read in this file, so I'm going to run my logistic regression here. So my logistic regression is your GLM, that is the one that we normally use, and our dependent variable is retained, and our independent variable is average order. And we have to specify our family, and it will be a binomial family, and for our case, we could use as a logit. Okay, we could obviously change this to profit, clog, and so on, but for now, we're going to use logit. Okay. So the first step that we're going to do is that we're going to run this, okay, and let's see what we get here, okay. So I've ran it, but if I put in my logit, I don't get too much. What I'm going to do is I'm going to get a summary of it, okay. So I'm going to run this line, and it gives me a summary of the output of the logistic regression line that I have ran, okay. So it seems that the point estimate for average order, which is the part that we're interested in, is 0.00467. Okay, doesn't seem to be a very nice looking estimate in terms of whether it's going to be a significant value or not. It's very close to zero, and we don't have a p-value that is high enough. But the thing about the summary is that it doesn't give too much in terms of like the odds ratio and the confidence interval. So what we have to do is that we would actually have to convert this in terms of the confidence interval and place it with the exponent function just to make sure that we want to have the confidence interval and try to see whether this was a significant value or not. So what we're going to do here is that we're going to run these three lines, try to get the confidence interval. Okay. And if I run these three lines, what it's going to give me is that it's going to give me a confidence interval for the point estimate without using the exponent, and it's going to give me a confidence interval using the point estimate with the exponent that is given. Okay, so without the exponent, you probably notice that it is minus 0.00119 and so on, and our upper is 0.002. It seems that it's containing 0, so it's not too significant. Okay, and I have two different types of confidence intervals that use the exponent here. Okay, the bottom one is the one that is using the standard error, and the top one is what we using for a clog. Okay, so there's actually a little bit difference, but we probably notice that the value is almost very much identical though. Okay, so in terms of the one that we're using, the standard error, that's the probably the one is most commonly used, which is the default one. Okay, so it seems that the average order has a point estimate of a lower confidence interval of 0.9987 and so on, and 1.002, which seems that it contains 1, meaning that it is not a significant, meaning that the odds ratio of retaining a customer over odds ratio of losing a customer is equal. So even though I spend another dollar or the customer spends another dollar, it doesn't mean that that person will likely to stay or likely to use. So it is irrelevant. Okay, so It seems that we ran one type of logistic regression with one independent variable, which was the average order, and it seems that that's not the significant part. Okay, in this case, let's do a different one. I'm going to use doorstep as my independent variable, and I'm going to run everything. And in this case, I want to get my coefficient as well. Okay, and let's see what kind of a value that I would get if I run all this. Okay, and this is my coefficient. Okay, so the outputs are very similar in terms of format, but now I get a point estimate for doorstep is 1.01 and so on. It seems quite likely to be significant, and if I look at the p-value, yes, it seems to be significant. Okay, and these are my confidence intervals here. Okay, if I use it for the exponent case, it has a lower confidence interval of 1.79 and an upper of 4.44. Okay, it does not contain 1, so it seems that this estimate is significant. And if I want to look at my point estimate, I would use an exponent coif function here. And it seems that for doorstep, it's 2.75 roughly, okay? Which means that if a customer uses a doorstep delivery service, this person is 2.57 more likely to be retained than to be lost as a customer, okay? So it seems that this is a pretty significant service in terms of trying to check whether the customers are going to retain or not, okay? So today we kind of looked at how to run a logistic regression, and these are the functions, and you can find this on my webpage, and hope you enjoy this video. Okay, thanks.